We present text-to-SQL domain adaptation via human large language model collaborative data annotation. This work was done during the first author's internship at Adobe. In practice, it is expensive to keep annotating text-to-SQL data for continuously evolving schemas in real-world applications. It brings challenges for model training and evaluation in these evolving domains. To bridge this gap, we propose SQL Sense, an interactive text-to-SQL data annotation system. SQL Sense streamlines the creation of high-quality text-to-SQL datasets through collaboration between humans and large language models in a structured workflow. There are 4 main steps. In the first step, since it is usually mentally demanding for annotators to understand and aggregate complex database schemas, SQL Sense visualizes the uploaded schema as a graph and allows users to freely edit it to adapt to new demands. For example, users can add tables or columns, change data type, document each entity, and specify primary key or foreign keys. Users can download the updated schema for future use. Based on the schema created in the first step, in the second step, SQL Sense populates the database with synthetic records to create an executable sandbox database. Users can create thousands of records with one click. A big challenge in text-to-SQL data annotation is that it is hard to reasonably come up with new queries from scratch. To bridge this gap, SQL Sense samples SQL queries under the sandbox database using SQL grammar. All sampled SQL queries are executable on the sandbox database for users to check the results. Then SQL Sense explains the SQL step-by-step in natural language and the corresponding sub-questions each step addresses, helping users better understand the query. Then SQL Sense suggests the corresponding natural language question of the SQL query. SQL Sense shows similar real-world queries so users can better evaluate the quality of suggested data. To verify the SQL natural language equivalence, SQL Sense normally aligns the natural language question with the SQL query through the step-by-step explanation. As users hover over each step, the corresponding components and chunks are highlighted in yellow. Based on this alignment, SQL Sense suggests potentially irrelevant text in the question and highlights them in red. In this example, fit is not defined as a unit based on the schema and the SQL query, so users can delete it. SQL Sense can also suggest missing information in the question. For example, the third step maps to the text ascending order. If user deletes this, the third step will be highlighted in red, suggesting information for this step might be missing in the question. To fix this issue, user can easily click the Inject button to correctly update the question. To further help the user to verify the quality of the data, SQL Sense provides a post-annotation report as well as a confidence score ranging from 0 to 100. Given the high data quality score, user can consider accepting the data and collecting it on the right. In addition, SQL Sense also provides the option to fully automate the data annotation process for scalability. In the last step, considering that a good dataset usually has a diverse coverage of tables, columns, query types, and so on, SQL Sense allows users to monitor the dataset composition in multiple interactive chart views. This helps users avoid annotating repetitive data and focus on annotating less covered database entities and query patterns. In our user study, we recruited industry engineers and scientists who frequently work with database queries. We asked participants to annotate text-to-SQL data manually using a conversational AI assistant, ChatGPT, and using SQL Sense respectively. There are 5 key findings. First, SQL Sense significantly speeds up text-to-SQL data annotation. Second, SQL Sense significantly reduces errors in the annotated data. Third, SQL Sense achieves the readability and naturalness comparable to manual annotation. Fourth, SQL Sense leads to more diverse annotated data. Lastly, SQL Sense significantly reduces cognitive load of text-to-SQL data annotation. Thanks for watching.